Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which finds vertical width of a binary tree. First, let us take an example. In this image, the tree contains 6 vertical lines, which is the required width. Now, let us see the approach. We take in-order traversal and a temporary variable. If we go left, then temp value decreases, and if we go right, then temp value increases. Assert a condition in this. If minimum is greater than temp, then minimum is equal to temp, and if maximum is less than temp, then maximum is equal to temp. At the end, we print minimum plus maximum, which is the vertical width of the tree. Now, let us see the algorithm. Let us also have a sample tree to test our algorithm. We pass the root node, which is 7, to getLength function. Also, we take two variables max and min and initialize it to 0. Next, we call the length util function with these values passed as parameters. Also, we take a cur variable and initialize it to 0. Now, in the length util function, since root is not null, we traverse left along with max, min and cur -1 passed as parameter using a call stack. Again, we pass the left child of 6, which is 4, along with cur -1. As root is not null, we pass the left child of 4, which is null. So, root will point to null. As root is pointing to null, we return to the previous call. We continue execution for node 4 and now check if minimum is greater than cur. As it is true, we set minimum to cur. Hence, minimum will be equal to -2. Then we check if maximum is less than cur. As it is false, we traverse right. So now we pass the right child of 4, which is also null, along with cur +1. Since root is null, we return to the previous call and finish execution for node 4. Execution for node 6 is resumed and we check if minimum is greater than cur. As it is false, we check if maximum is less than cur. As it is false as well, we pass the right child of 6, which is 3, along with cur +1. Again, as root is not null, we pass the left child of 3, which is null, along with cur -1. Now, as root is pointing to null, we return to the previous call and resume execution for node 3. Next, we check if minimum is greater than cur. As it is false, we check if maximum is less than cur. As it is false again, we pass the right child of 3, which is null, along with cur +1. As root is null, we return to the previous call. We finish execution for nodes 3 and 6. Execution for node 7 is resumed, and now we check if minimum is greater than cur. As it is false, we check if maximum is less than cur. Since it is false, we pass the right child of 7, which is 5, along with cur +1. Since root is not null, we pass the left child of 5, which is null, along with cur -1. As root is pointing to null, we return to the previous call. We check if minimum is greater than cur. Since it is false, we check if maximum is less than cur. As it is true, we set maximum to cur. Next, we pass the right child of 5, which is also null. Again, as root is null, we return to the previous call. Execution for node 5 is over. Execution for node 7 is also over, and we return to the getLength function and return the absolute value of minimum plus maximum +1. So, we return 2 plus 1 plus 1, that is 4, and that is the width of this binary tree. With this, we finish execution for this program. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.